Okay, today's topic is going to be about solving trigonometric equations using factoring. This is from Trigonometry, or MAC 1114. My name is Kurt Overhiser, and I'll be your host as we do, I think, about 3 examples. The examples that we are going to take are taken from the textbook entitled Trigonometry 5th Edition by Larson and Hostetler. The first one we're going to look at is found on page 232, problem number 23. It states that three times the tangent cubed of x is equal to the tangent of x. It would be tempting when you look at this equation to go ahead and divide both sides by tangent, and that way on the left hand side you would get a tangent squared, but it's not appropriate to do that here because you may lose some solutions. So what we're going to do is, instead of dividing, we're going to be subtracting the tangent of x from both sides. And then we're just going to go ahead and factor this. So if you look to the side right here, where my little arrow is pointing to, if you can factor this, 3y cubed minus y equals 0 from, just a regular beginning algebra class, then you can factor this trigonometric equation. It's basically the same thing. So let's go ahead and factor the 3y cubed minus y equals 0, and we'll factor it out. We'll factor out a greatest common factor of y. Like that. And then we can set each factor equal to 0 using the zero product property. And so we end up with that. So we're going to basically go backwards and use this idea that we just worked here on the side of the margin. And we're going to factor out the greatest common factor. Instead of being y, we're going to factor out the tangent of x. And we're left with 3 times tangent squared of x minus 1 equals 0. And then we're going to set each factor equal to 0 because of the zero product property. And the tangent of x is 0 whenever the sign is 0, and that happens in multiples of pi. So if we let k be an integer, and then x equals k times pi, and then for the other one we'll get tangent squared x equaling 1/3. And then if you square root both sides, you can get tangent of x equals so we get tangent of x is equal to 1 divided by the square root of 3. And if you know that that happens to be a special angle of 30 degrees, so that would be pi over 6 radians. So x equals pi over 6. And then we're going, since the period of the tangent function is pi, we have to remember to add multiples of pi to our answer. But we're still not done, because when we take this when we extracted the root, when we took the square root of both sides, we have to remember to put a plus or minus in there. And so the tangent of x is negative in quadrant 2, and that corresponding reference angle in quadrant 2 would be 5 pi over 6, and then we add to that multiples of pi to it. Again, k is an integer. Okay, so these are our three solutions, and that is the end of example 1. Our next example is going to be taken from page 232, homework problem number 24. And this problem states that you're supposed to solve this equation. You're supposed to solve 2 times the sine squared of x equals 2 plus cosine of x, and we're going to solve it on the closed interval from 0 to 2 pi. So what we'll do is we have to make use of a Pythagorean identity that we're going to be using. It's the most famous identity of all. It says that sine squared x plus cosine squared x equals 1. And if you solve for sine squared x, you get 1 minus cosine squared x. And this is the identity right here that we're going to be using in this problem. So the way we're going to do this is we're going to look at the sine squared that you see right here, and we're going to rewrite it with that identity that we showed you in the margin. So that gets rewritten as 2 times 1 minus cosine squared x equaling 2 plus cosine of x. And then if you distribute the 2, you get this. And then what I'm going to do next is I'm going to rearrange some terms. Notice that there's a 2 on both sides of the equations that you can subtract 2 from both sides of the equations, and they'll end up canceling from both sides. And then what I'll do is I'll add the 2 cosine squared x to both sides. So I'll end up with 2 cosine squared x plus cosine of x equals 0. And then we're going to do like before. We're going to look over at the side over here, and if you can factor this beginning algebra problem, you can finish this trigonometric equation. So the corresponding equation would be 2y squared plus y is equal to 0. We're in essence using a substitution where we are letting y equal the cosine of x. So you factor out the greatest common factor, which is y, and then you set each factor equal to 0 using the zero product property. Okay, so we're going to go back to our original equation and factor it in the same way that we just did in our margin, except this time instead of factoring out a y, we're going to factor out cosine of x. And then using the zero product property, we can get cosine of x equals 0, or 2 times the cosine of x plus 1 equals 0, which also, if you solve for cosine of x, you get cosine of x equals negative 1/2. Okay, so we're almost done here. Notice that we're working on the unit circle from 0 to 2 pi, and we know that the cosine of x is 0 in 2 places along the or around the unit circle. So here, for cosine of x is 0, we get 2 answers. We get, if you remember your unit circle, pi halves would be one place where the cosine is 0, and then the second place would be 3 pi over 2. And then for the second factor, the cosine of x equals negative 1/2, the cosine is negative in quadrants 2 and 3. And so we're going to get 2 answers for that. We're going to get x is equal to 2 pi divided by 3. Because the reference angle here is going to be 60 degrees. So, and the cosine's negative in quadrant 2, so that would be 2 pi over 3. And then cosine is also negative in quadrant 3. And that would give you 4 pi over 3. So these are the solutions to our problem. Get 4 solutions. Pi halves, 3 pi over 2, 2 pi over 3, and 4 pi over 3 for this example. Okay, so our next example is going to be taken from page 228, example number 6. And we're supposed to solve this problem. Two sine squared of x plus 3 cosine of x minus 3 equal 0. Again, we're going to use the Pythagorean identity that the sine squared of x equals 1 minus cosine squared x. So we use that right off the bat, and we put 2 sine squared, we'll replace it with 1 minus cosine squared of x plus 3 cosine of x minus 3 equals 0. And then if we distribute the 2, we get this. And then what we're going to do is just kind of rearrange some of the terms around. And when I rearrange the terms, I'm going to add 2 cosine squared x to both sides as a first step. And then a second step, I'm going to subtract 3 cosine of x from both sides. And then you'll notice that 2 minus 3 is negative 1. And so I'm going to add 1 to both sides as a third step. So doing all these three steps in one, we get this. 2 cosine squared x minus 3 cosine of x plus 1 equals 0. Okay, and then for here, this happens to be a quadratic in cosine of x. So if you look at our beginning algebra example, here's a good problem that's associated with this problem. Would be to factor 2y squared minus 3y plus 1 equals 0. So to factor this, you put down 2 sets of parentheses, and then you look at the leading term 2y squared, and the only way to factor that would be 2y and y. You look at the constant term plus 1, and that means that they both are positive or both negative, but because the negative's in the middle, they both have to be negative, and the only way to factor 1 is 1 and 1. So those are the factors that we're going to be using. Okay, and using this idea, we're going to go back to the original problem, and if we think of y as the cosine of x as the basis for our substitution, we're going to factor this into 2 times the cosine of x minus 1 multiplied by the cosine of x minus 1 equals 0. And then we use the zero product property, and we do 2 times the cosine of x minus 1 equals 0, or cosine of x minus 1 equals 0. That tells us that the cosine of x is either equal to 1/2 or cosine of x equals positive 1. Okay, and for the first factor where the cosine of x equals 1/2, that's positive, and we know that the cosine is positive in quadrants 1 and 4. And in quadrant 1, we would get pi thirds, and that's in quadrant 1. And then in quadrant 4, if you remember your unit circle, we would get 5 pi over 3. Okay, and then for the second factor, where the cosine of x is equal to 1, that we can solve that easily. That x has to be 0 right there. Okay, now in this problem, unlike the previous problem, we're not restricting ourselves to any finite interval, so we have to solve this along the entire real number line. So in order to do that, we have to take advantage of the periodicity of the cosine function, and its period is 2 pi. So we have to take each of these answers that we found in going around the unit circle once, and then we have to add multiples of 2 pi. So we will add 2k pi plus 2k pi here, and then plus 2k pi here. K can be any integer, both positive or negative or 0, and so these would be our final results right here. Okay, so that we just went through 3 problems where we did some factoring. We did first 2 problems. We factored out a greatest common factor. We also had to use some Pythagorean identities, and the last one we had to solve by factoring a quadratic trinomial. So hope this helped, and good luck in your studies. Okay, bye-bye.